This video is brought to you by IXL, used by millions of students worldwide to get ahead in math, English, and more.
Did you know that you can integrate a function using its graph? Let's learn how. If you're asked to evaluate the definite integral of a function f of x with respect to x over an interval a to b, that is the same thing as being asked to find the net area between the graph of f of x and the x-axis over that interval. Essentially, we can graph f of x, add up all the area above the x-axis, and subtract all the area below the x-axis. And that result is the value of our definite integral. Notice that because we subtract the area under the curve that lies below the x-axis, it is possible for us to end up with a negative value in these types of problems. Let's apply this idea through some examples. What's the value of the integral of negative 1/2 x plus 3 dx from negative 2 to 6? We know the graph of negative 1/2 x plus 3 is a linear function, so let's use that to our advantage. We can find the net area between that line and the x-axis over the interval from negative 2 to 6. The area above the x-axis is in the shape of a triangle, so its area equals 1/2 the base times the height. The base of the triangle goes from negative 2 to 6, so it has a length of 8. And the height of the triangle goes from 0 to 4, so it is length 4. So the area is 1/2 times 8 times 4. There is no area below the x-axis on this interval, and so there's nothing to subtract from the triangle's area. Simplifying, we find that the net area, and therefore the value of the integral, is 16. How can we evaluate this integral using a graph? Let's start by trying to graph our function. We can rewrite the function we're integrating as y plus 4 squared plus x minus 5 squared equals 9, which we know is the equation of a circle centered at 5, negative 4 with a radius 3. But we don't want the whole circle since we're taking the negative square root in the integrand. We only want the bottom half of our circle. So this is the area that we're looking for. The area between the semicircle and the x-axis is all below the x-axis, so we know that our final answer will be negative. It also looks like we can break it apart into a 6x4 rectangle and a semicircle with radius 3. The area of the rectangle is 6 times 4, and the area of the semicircle is half of pi r squared, or 1/2 pi 3 squared. Combining these two areas and distributing the negative, we get negative 24 minus 9/2 pi as the value of this integral. Great job! Let's try one more together. For our final example, we are integrating the function 3 times the absolute value of x minus 6 from negative 4 to 5. Can you visualize this on the graph? The integrand is an absolute value function with a vertex of 0, negative 6 and a vertical stretch factor of 3. We are looking for the area between the x-axis and this curve, from negative 4 to 5. Notice how two of these triangles are above the x-axis, and so we'll count positively towards the net area. And this triangle is below the x-axis, and so we'll count negatively towards that net area. The area of each triangle can be found by multiplying half its base times its height. So we get 1/2 2 times 6, plus 1/2 3 times 9, minus 1/2 4 times 6. In total, there are 39 over 2 square units of area above the x-axis, and 12 square units of area below the x-axis, for a net area of 15 over 2, which is the value of this definite integral. Nice work today evaluating integrals of functions by finding the net area between their curves and the x-axis. Keep practicing and improving your skills.
Head over to IXL.com for more practice on this skill and thousands more videos in math and language arts.